You're up.
Good. Thank you very much. Bill Ragsdale here. You all know I was the founding president of the Fourth Interest Group and helped Sparkplug it for about 3 or 4 years. And then we went professional management, which carried it on for roughly 20 years. So we are going to go to screen share. And we are live. If I can make the screen simplify as much as I possibly can. So today we are going to investigate or pontificate on object-oriented programming. Reminds me of the people, the saying that said, those that can do and those that can't teach. Well, I'm now an expert in object-oriented programming for about 1 month. And so I thought I would teach something about object-oriented programming. And I have had a long-term project toward financial analysis. I've used software, commercial software that is very extensive, very, very well done, very, very rich, but non-modifiable. They're flexible, but they have their limits. And I have this huge security data file accumulated over the last 40 years. And the analysis software has a weakness in that normally it will only analyze one security at a time. And you can't do correlations between multiple securities or multiple databases. So I need to get a more robust programming style going. And so I've had it on the back burner for quite a long time and accumulated pieces and piles and little bits. The format that's used originally was called CompuTrack, and then it was called Metastock by the active corporations that utilized it. And there have been three dominant vendors in this arena, and each of them has made some additions to the format over time. So it comes out to be a mix in the data files of a certain amount of binary, plain old bytes, bits, integers, and so on. And then the core of it is a Microsoft QBasic. This was Microsoft Basic float format from about 1986 or so. And originally it was rather obscure, only in a book or two that I found. And now, of course, on the internet, the format reference is quite readily available. And then also, later years, they began to use the IEEE 32 float, and I used Win32 that uses IEEE 64-bit floats. So I'm using that as the common denominator. Everything I read in comes out to be the IEEE 64-bit floats. And as I said, I'm using Win32. And as a commercial for that, it is an unbelievably rich toolkit. I won't go into all the whys and wherefores, but you can do everything with this. Win32 is written in Win32. It has its own recompiler, can do closed applications, turnkey applications, and it has built right in, it has a core part of it is object-oriented programming, because once they got into the user interface of an integrated development environment, an editor, and so on, Tom Zimmer and Andrew McEwen wrote that in object-oriented programming. So I have learned and expanded into that. We'll do a quick introduction on object-oriented programming. This would have helped me at the start, because as so many pieces of technology, it has sort of an opaque vocabulary, their own little in-house vocabulary of things. And once you realize that the vocabulary they use relates to non-object-oriented programming vocabulary, For example, a message is nothing more than some stack parameters. All of a sudden, it becomes a lot clearer. So we're going to look at this from a two-level standpoint. We're going to see a report generator that does the overview of all the securities that are available, and then a report generator for each security itself, which goes by weeks. Security analysis is done generally by day or week. Occasionally, it's done by month, and the work in the last 20 years has gone by time. So it goes what they call tick by tick. It goes each transaction reported in real time. And I use weekly information. That's fast enough for what I need. And finally, we'll see a report on each individual, what a report on individual security looks like. All of this is to open the door to the analysis of the data. But first, I've got to be able to get it organized to look at. So to briefly cover object-oriented programming, the workhorse element is the object, and this is anything you want it to be. In my case, the starting point is it's a file. And so the object is a file, and then it contains within it the mechanisms necessary to access files. Later on, an object could be an analysis method like a moving average. So we could have an object that is a moving average, and when you couple that object to the object of the file, it would then do a moving average on the data in the file. But that's getting ahead. When you have a number of objects, these are grouped into a class. In reality, it starts the other way around. You define a class, and then within it, you then create individual objects, and the objects share characteristics, as we'll discuss. The objects have snippets of program associated with them called methods. This is just a fancy word for a colon definition, a specialized colon definition. So when you want to talk to your object, you create little short pieces of program, and they are tightly associated with that object. And the methods are forth programs. They have a specific, slightly different, some limitations, not quite a syntax, but some limitations. So you follow the rules for methods. And finally, a given method can be associated with the objects in this particular class, but there's a hierarchy. And so I call it inheritance. Each object can inherit characteristics of a higher level object. And so the methods can go up and down that ladder, and they can actually activate or access capabilities from the higher level. But even though the method is common and specific to the object it's associated with, the object itself, each object has its own memory allocation. So this is very important. You're sharing the code, as say methods are being shared, but each object has its own memory allocations. So it has a number of parameters that are available. And this is actually very, very refreshing and valuable, because since each object has its own memory allocations, it's very similar to local variables. Once you're accessing and working inside the object itself, you have its parameters available with no further effort. They're there, they've got names, they're directly accessible, and I find this reduces your stack manipulations very, very greatly. So here's an example. The word colon class, it's in green at the top left, is a definer for classes. And so in this case, it's defining what I'm calling the object definer. It is an object, but the name of the object itself will define actual objects. So once we've created this class, the name of the class is a definer, and it will later define the objects. And then next after that is the memory allocations. Here, it's like a classical program. At the beginning of the program, you define memory allocations, variables, constants, bits, bytes, um, even a little mini database arrangements to have named areas in an array. The :M items are methods. They are really a disguised colon definition with particular activities going on. There's a fair amount of machinery going on in the background behind all of these words. The beauty is that the complexity is concealed. It's going on behind the scenes. So between the :M and semicolon M, you have what is essentially fourth code. The class definition is ended by semicolon class at the end. So this is actually a definition. I'm defining a class called filers. I was going to use file, but that word is reserved within 132.4. So my word filer slash defines objects associated with data files. To facilitate that, there are 200 bytes associated with path. This is the Windows path name of directories and subdirectories to get to the file, and then I've allocated 20 bytes for the file name. In this system, there's only about 6 bytes for the file names. To support the file access, I need the Windows handle, the size and bytes of the file. I'm using heap allocation memory, so I need its location from the heap. And the offset, each of these files is essentially a database of records, and the offset, or the size between records, is in offset. So the beauty of this is once you're in and programming inside this defined file, you have immediately available all of these resources at your fingertips. The methods associated with this are what you would probably assume logically. The set name accepts a counted string. From the address in the count, it accepts the counted string, and it puts it into the name array or area. Place is a very powerful Win32 word that will place a counted string into memory. So set name transfers the path name in, then you give it the file name, and now it massages the path into its full configuration. So now you have the path name and the file name together. Executing open loads the file handle. So this goes through the Win32 components, which are ANSI standard words, like the open file. So from path, we count the string, we pass, we say we want to read only and open the file. And then there's a little error control, and the handle is now loaded. The size word extracts how many bytes are in the file and loads the internal integer value size. Allocate goes to the Windows and requests memory allocation, grabs that allocation according to size using malloc, and loads the location in memory, and closes the file access for housekeeping. Really, the word that does all the work is read, in green there at the top left. This actually executes all those previous words. It does open, it does size, it does allocate, reads the file, and closes. Now, those words above are factored primarily for me for testing. The entire read process could be done in this one word by itself, but for testing, I factored them out. The set offset brings in externally, because once we create a file, we need to tell it what the record offset is. The to address is very powerful. It's a short, very powerful word, but this converts the external file identification and an offset, and it reaches into that heap memory access and gets us a data element in memory. So this is the way we reach into memory, and you see it uses the word location. It does some computing at a time. It takes that offset, adds it to location, and it returns then the physical address in memory within that memory allocation. Release is the memory allocation. If you don't use release, you can get memory leakage because you keep making allocations without releasing the memory. So that's very important. And class init is a setup process. As I mentioned before, the methods on opening the file could have been combined and simplified. Probably in future work, I'll bring them down into it, that single word read. So the file of interest right now is called eMaster. This is the master index. It's kind of like a directory listing in Windows. It lists, it's a list or an index of all of the security files in a given subdirectory. The DAT files, DAT files are data files, and each data file covers one security over time. In my case, each data file has about 40 years worth of data. So we're going to begin to use the object-oriented programming methods. That filer slash followed by eMaster. Very simple, but it has now created the object eMaster. And so all of the programming and memory that we just saw is immediately accessible by eMaster. So you've concealed the complexity. Underneath eMaster is all of those resources that we just saw. After opening eMaster, we want to initialize its internal components. The most essential is to set the offset. So we say 192 set offset eMaster, and following the terminology of object-oriented programming, we formed a message. The message is 192, and then we pass that to the method set offset, and it's associated with the object eMaster. So we have now sent that parameter into eMaster, part of its setup, and it now knows the offset between records. We pass it the string, which is with the s-quote eMaster, and that sets the name of the file that we're going after, which is eMaster. There's no extent, it's just eMaster. The protopath is external, and that is the full string definition of the path. So that formed the path. Finally, we say read eMaster. At that point now, the object has come to life. It has its memory allocation. Once we open eMaster, all this code executes. The eMaster object is now live, and it has allocation, and it now contains all of its information. It's about 20 kilobyte, if I remember right. And there are a number of fields within eMaster, and I'll skip the word definitions of those. They're kind of mechanical. That kind of look like Bill's does, where we define each field within eMaster and what its offset is and its location. So now we're using these data location words. We want to display one line from the eMaster file. So if we say eMaster line and associate it with the file ID, that is the name of the object. So we give it the name of the object, say eMaster line, and it will pull out one line of that eMaster report. The DAT file or data file number is each file is associated with a serial number. It has a symbol, it has a name, it has a first date and a last date. So in looking at the eMaster contents, we want to know the file number, we want to know the symbol that's used and in the investment community, its friendly name, and then the span of the data information available. And then once we have the ability to do single lines, we then we generate the full report. So in this case, we have the EM header, which I've not shown. We'll see it in just a moment what it looks like. It's a string header across identifying the fields. And then we go the number of files present. Remember, this is going on inside the object, and it knows the number of files that are present. We add 1 to it, and we do a do loop from 1 to the number of files present. Over the do loop, we simply take that I, which is one file entry, one security file, and use the EM line to display that, and loop over that for the number of files that are present. This is the beginning of that eMaster report, and you can see the header has the file number. It has the ID is the number, and then what's called file number is actually the file name. They use a 2-level system. The files have numbers, but they access them by essentially by a record number. Symbol is the QSIP on the security, familiar ticker symbol. Name, the first date, last date. So here's what the full report looks like. We can see file ID number 1 actually has in its name, it's called file 1. But if you go down the line and look at number 4, if you've been on file ID number 4, the ID is 4, but the file number is 5, because actually file number 5 is not in use. Apparently, it was created at one time and then deleted. So the system adjusts for the fact this file is missing. The symbols, again, are what's called QSIP, or they're the ticker symbol that is associated with this. These are all mutual funds. There are 5 letters, and they all end in X. Denotes they're a mutual fund. The names of the funds are given, and then the first date and last date. And you can see here, I've got about 30 years worth of data from July 6, 1989. And this is a frozen data set that I use for testing. So it was frozen and locked at 2023. And of course, I have maintained the data weekly ever since. So every Friday evening at around 8 or 9 o'clock, you can catch me downloading, freshening my database. So now let's look at the data file. In this case, it's a file, it's an object. So we use filer/ again, and now we create a data file object. And this is a similar but different object, which has its parameters adjusted to look at the data objects. In this case, the offset is only 20 bytes. There are many more records, and they're much shorter. So we tell MS Data that its offset is now 20. And remember, we are using these methods from this class of objects, but each one has its own data is independent. So it's shared methods, individual data. This is a very key word, and it's very, very extremely powerful, and yet it's going on kind of hidden inside that data definition, object definition. To data is that we give it a week number on the calendar. So we have a week number. Current database has about 1,800 weeks, 1,800 weeks. So we give it the week number. I give it the offset for an item, and that offset could be the date, the high price, the low price, the close, or the volume. So this is reaching into the database, pulling out a particular field. And look at the simplicity. All you do is you execute the method to address and associate it with the object, which is the MS data files. So on that basis, we have now concealed all the complexity. We're reaching into that data file and we pull out information for 1 week. This is the code to actually read the data file. I've reorganized this in my later generations. It's a bit simpler and a bit more general, but this sets the parameters inside the particular file we're talking about. It specifies the file. It generates the file name. The file names actually begin, or the file names are file a number dot dat. That's the file name. So it builds the path. Down at the bottom in green, it sets the name, the file name, it forms the path, and it reads the data. And now the data file is active for a particular security. So that data file now has access to one security, and it knows its values, like its number of records present, the dates, and so on. So this is our method to access the individual records. The dat records gives us a number, which is the total number of records available. In this case here, generally it's about 1,800. By giving it a week number and the dat date, we will now get the date as a floating point date number. So again, very brisk, clear, clean protocol. We just give it a week number. We open a security file and then just give it a week number, and now we've got the date. Notice internally it's a little bit complicated. It actually is in the, when I say MS IEEE 64, the MS is the metastock format that Microsoft QBasic format. So it grabs a 32-bit value in that metastock format, converts it to IEEE, but for the year 2000, for the year for the Y2K problem, they had to come along with a patch for the Y2K problem. And so this adding 1900,000 as a floating point adds the offset to create a legitimate date. The original databases only used a 2-date year integer, and now we've expanded to a 4-digit year date. So once that word executes, we now have a 8-digit year. We have year, month, date. Year, month, day. Dat high gets us the securities high price for the week. Low gets us its low, close, and volume. So these are the points. If you're going to do analysis on the close, you would set up a data series of week numbers, get the data closes, and then process them. Again, we see very simple syntax once we're in operation. Here's our report generator for the data file. Dat line, you give the week number, and it will give you back the information for a particular week. Remember, the weeks go from 1 to a max number, currently around 1,800. So the dupe 4.r 4 spaces shows what week number we're accessing. Then we actually see the direct expression of the date itself, the high value, the low value, the close, the volume. My word, f.r is a floating point formatting number. It takes the floating numbers and puts it into an 8-digit wide field with 2-digit decimals. The Win32 has the tools in it for floating point formatting, but the internal choices are very, very limited. So about a year ago, I did a big talk on floating point formatting, and this is the usage of that. So it's a very general word. It will do left justified field, right justified fields, and a variable number of decimal points. And the number of decimal points can be positive or negative. So if you say -2, it actually rounds off to the nearest 100. If you say 2, it gives you 2 decimal digits. It's very, very general. It's really, really works well. And finally, for the data report itself, this is it's a wrapper that goes around that data line. In this case, it sets up the header. It selects the data records. In this case, it's for exploratory use, and whatever date you give it, it'll give you the next 20 weeks. So it's a 20-week report. And once it starts to work, you have a simple do loop where you increment by I through the weeks, look at one data line at a time, cards your turn at the end of the line, and you loop. This is what the header looks like. It's very informative. It's telling you the name of the security, in this case, blue chip growth. It's QSIP format. And again, repeating that information we saw on the previous file is telling you its ID. It's telling you its date, its file number, file name, and then the dates. And in use, here we go. In this case, when we say record 100, what it means is the 100th week in order in the file. So we're going back to 1990. This is week number 100 associated with this file. The record number means nothing other than locating a record within the week. It's a different task to be able to find dates by to find the records by their date. It's a good bit more involved because we're having to translate the calendar week number back to a search value to search the file, but that's necessary. Then we see the individual prices at that day. So on day number 102, this was, sorry about that. Day number 102 is December 14th, 1990, and we see the prices of the security were around $14. The volume column is interesting only to me. The volumes are not provided on mutual funds, but I use this column as an adjustment parameter for dividends. So periodically, the mutual funds pay a dividend, and so that volume column contains an adjustment factor. So on a historical basis, I can go back over 30 years of a security, and I can find out its true value based on what the dividends have been over time. So that is the presentation. What we're seeing is that the value on object-oriented programming is we can declare that that object with all of its internal machinery and support, and then once it's done, you can set it aside, and you have easy access into that in a very regular, very systematic, very resource-rich capability. As I've done this over the years, I've built up an inventory of support functions, date handling. Some time ago, a couple of years ago, we went into date handling. We'll probably come back to it and look at it again. Floating point conversions, we've looked at in the past. And what I found out was, I think I'll mention in just a moment that we'll come back to in just a second. And then what lies ahead is to build a catalog of analysis methods. And as I said, they'll likely be object-oriented programming. You take a given class of objects like moving averages, you build an object that knows how to handle moving averages, and you put into it parameter sets of the different types of moving averages, and you're ready to go. And as a final comment, at the beginning when I started this journey, trying to decode and learn to use that original obscure QBasic format, it was really difficult working down to bit level, having to shift and using fourth and using 132 fourth and using floating point having to dissect floating point numbers and move them around. But once I developed some tools on it, and then when I had to start working on the Microsoft 32-bit format, or the IEEE 32-bit format, then, as you know, it gets easier. So baby steps, you struggle at the start, you learn the process, you develop some tools, and then now doing floating point conversions, are very, very straightforward. So that concludes my formal remarks. Do I have any questions or comments?
I'd like to know when you're going to buy a mutual fund and offer it for sale.
I did manage a mutual fund. I was a mutual fund manager in the early 1990s. I was the president of a New York Stock Exchange listed company. Can you imagine that? For my goodness gracious. I was the president.
We've all missed an opportunity.
I was the president of a New York Stock Exchange listed company. We had a board of directors. We had a ticker symbol, SUGTX, Sunshine Growth Trust, and it was NASDAQ listed on the markets there. And I ran it for a number of years, and I was looking for a retirement job, and I wanted something that had limited staff, but involved money, and well, that's it. It was something financial, limited staff, because I was going to retire. And so preparatory to that, I did two things. I started a newsletter. So I started a newsletter called Good Fortune, and I started the mutual fund Sunshine Growth Trust. Ran them both. After about 3 or 4 years, I found out that running a mutual fund was not appropriate for the lone wolf. You cannot do it you've got to have a marketing machine behind you. And I realized I would never get there. So I sold the mutual fund to another company. Another company took it over and maintained it. But the newsletter I could do a single solo man. So I published a newsletter for 25 years. Every Friday for 25 years, we had 1,500 issues. And Sunshine Growth Trust. And finally, after 25 years, I said enough's enough. And I sold it to another company run by a close friend. And so the subscriber base and my original newsletter were folded into his. So there you got more than you wanted to know. Thank you, Kevin, for the leading question. And I got to go very heavy on the brag coefficient.
Hey, Bill, were those the Fidelity funds you were doing?
Yes. I only do Fidelity funds.
Okay.
There are, at one time there were 6,000 securities available. Currently now it's about 4,000. Fidelity has a list of about 400, and I just focus on a list of 32. They are diversified, primarily sector funds. They're everything. There are about 5 bond funds. There are about 4 international. There are sector funds. There are money fund, bond funds. So in a list of 32, I have enough diversity. And my attitude is, if you can't make money on 32 diversified funds, you can't make money.
All right. If anybody has any actual questions about Bill's code. Doug, did you have something? I'm sorry I interrupted.
No, I just said
why not? Let's just talk about me. No.
I have other folks at miles to go before I sleep, and if it were up to me, I would be pleased to do that, Bill.
Go ahead. Go ahead. I yield the floor.
Doug, you are in the middle of a sentence and I cut you off. I'm sorry. Go ahead.
I willingly yield the floor.
Well, I'd say that some of the things you were displaying, like, I know that symbol. I owned that at one time.
Yes.
All right. If there are no questions about Bill's code, going once, going twice, going 3 times. All right. Thank you so much, Bill. If ever I feel the need to write objectionable code, I will refer to this on YouTube with great trepidation, frankly. Brad, are we going to do this screenshot at this time?
We certainly can. Not a lot of people
Okay,
showing
wonderful.
themselves on screen though, so please.
All right, if you would please all turn on your cameras. Bill is on. If you have your camera off, now's a good time to turn it on. If you're on the lam and you have been on YouTube all this time, there's little point in turning your camera off, but I say it anyway because it amuses me. Anybody that doesn't have their camera on at this time is a ne'er-do-well. If you want a camera sent to you, I will endeavor to do that. Message me offline. All right, lots of folks have their cameras on from my participants display. Thank you so much.
All right.
Brad, you ready?
I'm gonna try to look at the camera and hit the button. 1, 2. I've got it.
Wonderful. It's a little like lighting the fuse on a powder trail for a black powder charge. You know, the fuse is of indeterminate length. So Brad hits the button and then it happens at some point in the future. And speaking of Brad, it is incumbent upon you to introduce yourself because you're up.